Welcome to today's lesson on functional groups. We are going to begin the unit talking about different groups of atoms that appear on organic compounds that give them certain properties. These are what we call functional groups. So organic compounds can fall into what we call a family. So we're going to give each family their name, and each family contains a particular combination of atoms, and that's where that term functional group comes from. So the family will have a name, and then they will also contain that particular combination of atoms, which we call a functional group. Some families will have some functional groups in common, but also have an additional group as well. So understanding the effects of these functional groups allow us to predict the properties of that compound. So it's really important. We're going to start by talking about what these functional groups do to a molecule in terms of their properties. And then we're going to spend each individual lesson looking at the different organic families and what their functional group is. So the first property we're going to talk about is the polarity of a molecule. So I need you to remember way back to when we talked about bonding, and we talked about how to determine whether a molecule is polar or not. Do you remember how to determine whether a molecule is polar or not? Remembering that to have a polar molecule, we have to have what we called a dipole. So a net dipole, a positive end to the molecule and a negative end. So remember we were drawing those little cartoons so that we had one positive end and one negative end to the molecule so that they could interact with one another. We're going all the way back to that concept, only now we're going to start talking about these long chain organic molecules, but we're still looking for those types of atoms that are going to be what we call electron drawing. So they're going to be more electronegative than the rest of the compound. So they're going to create that negative side to the molecule. Okay, so if we take a look at the two molecules that are sitting here, and I know that if I check the periodic table, oxygen is much more electronegative than carbon or hydrogen. So anytime I have an oxygen on a molecule, that's going to make that molecule polar. So when I have a polar molecule, I have to take into account that the boiling point and the melting point are going to be higher. This is because, remember we talked about those dipole forces? Okay, those attractions between the molecules, and in some instances we also have hydrogen bonding. So we'll talk about that in a couple of slides here. If I have a polar molecule, I also have the ability for it to dissolve in water. So some of these organic compounds are soluble in water and many of them are not. So we're going to kind of figure out which ones are and which ones aren't based on their structure. And also whether they're soluble in non-polar solvents like oil and turpentine, and there are lots of organic solvents as well. Okay, so we're going to just take a look at each of these properties and how it sort of impacts based on the structure. So again, reviewing, just like I said on the last slide, what makes a molecule polar or a group polar? So we're looking at a more electronegative atom. Remembering I find that on the periodic table. All the electronegativities are written there for me. So we don't really have to look them up in this case. We did way back when in bonding, but now we're kind of know which ones we're looking for. And specifically for organic molecules, we are looking for oxygen, nitrogen, or any of the halogens. That's going to create a polar molecule. The shared electrons are held more closely to that more electronegative atom. They're pulling the electron density towards it, which is leaving that partial positive charge on carbon and a partial negative charge on that oxygen. As you can see here, oxygen is more electron drawing, so we were drawing those bonds as dipoles with the arrows pointing towards the more electronegative. So anytime we see oxygen or nitrogen or a halogen, I know that it's drawing that electron density towards it and it's leaving that partial positive charge on the carbon. When I have a molecule that's polar, I can talk about intermolecular forces. This is the dipole-dipole stuff I just mentioned. So the presence of a polar bond in a molecule increases the forces that attract one molecule to another. That's the intermolecular forces. So those red dashes indicate those intermolecular forces, the attraction from one molecule to the other. Now, why do I care? That's where the properties come from. When I have strong intermolecular forces, I have higher boiling points and melting points. It takes more energy to pull those molecules apart and make them change state. So more energy means an increase in temperature, so an increase in the boiling point and melting point. This is because of those dipole-dipole forces. Because of that, I can also say that it's going to be soluble in things like water. Water is a polar molecule. It's got a negative end and a positive end. So oxygen is more electron drawing than that hydrogen, so I've got that negative end at one side, positive end at the other. So if water can create those dipole-dipole forces, it can also interact and create dipole-dipole forces with another polar molecule. We will also be talking about hydrogen bonding. Hydrogen bonding is a special type of intermolecular force. Keeping in mind, I only have this force when I have an OH group or an NH group. So we'll be specific to the families that have those as a functional group. We're going to see these hydrogen bonds. So if I have hydrogen bonding, that means there is an increase in the boiling point and melting point, much more than another type of molecule that does not have hydrogen bonding. It's important to note, though, it's not just the presence of oxygen or nitrogen. It has to be the presence of oxygen bonded to the H, or what we call the hydroxyl group, or the OH group, and the nitrogen bonded to the hydrogen, not just the presence of nitrogen. As we learn more about these organic families, we will be putting them in order, ranking them in terms of their polarity and their solubility in water, and we're going to take into account the strength of their intermolecular forces. So we're always watching for these functional groups, and hopefully that's a good introduction for you to functional groups, and we're going to spend a lot more time on each one of them. But just so that you're ready to roll with the next part there, I've assigned some reading from your textbook. If you don't have your textbook available, there is one online for free right now. It's not exactly the same, but it will have the same sort of concepts in it. Or this PowerPoint should be enough. If not, you can always turn to the internet. So there are some questions on page 201, 1 to 6. I've put them here for you so that if you don't have your textbook at home, you can still do the homework. Okay, so good luck, and please, please, please ask me any questions for things that you don't understand.